We're going to have a new experiment. New experiment. We're going to play the game of Chuck-a-Luck. When I say play, we're going to analyze the game of Chuck-a-Luck, and we're going to talk about why you shouldn't play the game of Chuck-a-Luck. Well, what the hell? You should play the game. You should gamble if you want to gamble. I'm going to show you why. The point of this next experiment is going to prove to you why Vegas can keep its lights on 24/7, 365, while simultaneously not being near any bodies of water and keep its fountains and Bellagio running 24/7, 365. So we're going to explain that to you, hopefully with one example, which is one example here. So Chuck-a-Luck is a game played with 3 dice. They put them in this thing called a bird cage. What you do is you walk up with $1, and you lay your dollar on one of the 6 numbers, 1 through 6. Simple. You say, I'm going to bet on 5. Because they're tight. I'm going to bet on 5. And then the person behind the desk takes the barrel and does that to it. Okay? Spins around. And then when it comes to rest, the 3 dice in there fall to the bottom. And you anxiously look at how many 5s show on the dice. If there are no 5s at all on those dice, you lose your dollar. You anteed up your dollar and it's gone. That's simple enough, right? Fair enough. If one of the dice shows a 5 and the other 2 don't, you win your dollar back. So you bet $1, you win $1 back, you're zeroed out. If 2 of those dice show the number you bet on, in this case a 5, you win $2 back, which means you're $1 up. You paid 1 in, you get 2 back, you're $1 up. And the big one is, if 3 5s show, then you win $10 back, which means you clear 9. 9, there we go, 9. Okay, so everybody keep track of that? It's kind of tricky to keep track of. So let's write it down. Let's write it down. Turn this off, turn this on. Let's put this in distribution so we can analyze it. And I'm going to use a light color because we're going to change the random variable values. I'm going to have, if you will, a temporary random value variable right now. So let's say we bet on 5. Let's say we bet on 5. In Chuck. I guarantee I will not get good at that by putting in the term because that's me.
Chuck. Put the cap on the back.
Yeah, put the cap on the.
Chuck. I'll forget it's there. Chuck. I know myself that well. Chuck-a-Luck. It's amazing. The pen's about 2 inches shorter than the ones I used to use. That's all the difference things. Put my mouth. Okay, we're on 5.
That's not good.
That's not good. So in this column, I'm not gonna label this as a variable. I'm gonna call this number of 5s seen after the bird cage is spun. Now you guys buy that it doesn't matter what we bet on, whether it's 0 or whether it's 1, 2, 3, 4, or 5 or 6. It doesn't matter what number you bet on because it's all equally likely. We just proved that I think with 2 experiments that it doesn't matter what you bet on. So 5. And the reason I'm using 5 is I think I have this spreadsheet set up for 5. I think. So it's either 0, 1, 2, or 3. What I'm interested in, though, isn't that as the random variable value. I'm interested in how much money we make. That's what I'm interested in. I'm interested in how much money we make in this game. My goodness, it's a big engine. So I'm going to call X, and I'm going to put it in quotes, winnings. I'm going to put it in quotes as winnings. Because let's say you bet on 5, and you don't roll any 5s. What do you win?
Nothing. You lose.
You lose $1. Yeah. Remember, you bet $1 to play. That was the idea is you bet $1 to play, so you're actually down $1 right off the bat, aren't you? You're down $1. Yeah, fair? Hopefully that's fair. Good. Let's suppose you bet on 5 and you see 1 5. What's your winning now?
0.
You zeroed out. You won back your $1, so you're back to 0. What if you see 2? Remember what that was? You win 2 back if you clear 1, positive 1. And last but not least,
9.
Yeah, 9. Good. Everybody following those numbers? This is assuming you bet $1 to play. The winnings might look different if you don't account for the $1. It would be 0, 1, 2, and 10. But that's kind of cheating a little bit because you have to pay to play. Just like if you want to claim your insurance policy, you have to pay the premium, kind of a thing. So it's the same exact idea. We're going to tie that back in momentarily. All right.
But if we were in an economics class, it would be a sunk cost.
A sunk cost. Very nice. Very nice. That's totally fine. I don't understand that, but that's okay. I took one economic class in my life, it was a nightmare. Farley, what the hell was his name? Farley somebody. Wear a bow tie in class every day. It's an equilibrium curve. I'm like, dude, what are the equations? What equations? It's an X. I'm like, dude, it's magic. Renee, go, please.
Stupid question.
No, not.
How did you get 9?
Oh, because it's 10-to-1 payouts if you roll all 3 of your number, but you bet $1 to play, so they give you $10 back. But you lost the 1, so it has to be 9. Not a dumb question at all. Not a dumb question at all. Here's what I want to know.
We should make that net winnings.
You mean revenue, not profit?
Well, it's just a net. I mean, it's net zero.
Oh, so you're saying reflected it's a profit, like it's the cost taken out?
Yeah.
Can we not?
All right.
I mean, not because I'm being a bastard, but that would confuse the hell out of me, because I would think that means something else.
All right.
Or unless that makes you all, does that make you all comfortable? We just call it winnings, or there's net winnings?
I don't really know what net.
As long if you know what net, please put net if you know what it means. I don't know what it means, so
Sorry,
I'm gonna
accounting major.
okay. It's all right, accounting major. It's okay. Here's what I want to know. Here's what I want to know. On average, what do you win? I don't care much about the standard deviation of this, and you'll see why momentarily. You'll see why momentarily. But I do want to know if you walk up to this game and keep playing over and over and over and over. Somebody gives you a stack of $100 $1 bills or 1,000 $1 bills or 10,000 $1 bills and says go play Chuckle Up to keep track of your data, and you go okay and you leave.
Yeah.
And you go play this game over time. What's going to happen on average? $5? I just heard 5. Did I hear 5? $5. The average is 5. Okay, I like that. Good. Just out of curiosity, how come?
I just added the winnings and then
Cool. So 9
yeah.
divided by. Oh, if we divide 9 by 4, that'd be 2 1/4, wouldn't it?
Well, I counted 0 as a number.
Well, I would too. But if you add these numbers up, those cancel,
Oh, okay.
and that'll be 9 divided by 4 will be 2 1/4. So hell, on average, we make $2 1/4. Shit, let's go play. That means for every dollar we bet, we walk away with 2 1/4. Jerry's going, It's a Vegas game. What assumption? First of all, I love this idea, but what assumption are you making, Renee? Do you see what assumption she's making? Sydney, what assumption is she making?
That they're all equal, exactly.
She's making the assumption that every one of those outcomes is equally likely. And they're not. That's the kicker. That's how they get you in this game. That's how they get you in this game. These are not all equally likely outcomes. As a matter of fact, this is exponentially harder to do than this, which is harder to do than that, which is harder to do than that. Now the question is, what are these probabilities? That's the kicker. And I don't want to answer that question mathematically right now. I want to hold that after the chicken discussion next week. So instead, we're going to turn to our buddy Excel to bridge the gap between now and then. If it's okay with you guys. So I think this will do a pretty good job, if I can focus it correctly. There we go. This will do a pretty good job of keeping track of our results. We do not want to save that. We do want Chuckle. Oh, you can't see that. Next screen. Alrighty. So let me shrink it down so you can see what the hell's going on. Okay, same as before, except now I've got 3 dice. Now we're going to bet on 5s. Notice that the distribution I'm showing you looks exactly the same as the one we have on the board. Okay, I'm keeping track of the number of 5s, and here's the probabilities. Right now, the first roll is a 4, a 4, and a 1. That means I have no 5s rolled, which means right now my distribution is 100% likely I'm not going to roll a 5. But that's 1 roll, right? I better roll again. Ah, I got 1 that time. Yes? Roll again. None. Roll again. None. Roll again. Oh, 3 4s. Damn it, should have been on 4. Okay, let's just do this. Oh, look at this. It's actually updating. Hot damn, good. What do you think? How you feeling about this game? Are you starting to see why Vegas uses it? Oh, I think so. I think we're starting to see why Vegas uses it. I think we're starting to see why Vegas likes this game. Even though they don't use it much anymore. This game I've seen, I did go to Vegas not that long ago to go rock climbing, and I decided to just walk through a casino just to watch the ridiculousness. And I saw a couple of these game boards actually tucked under stairs collecting dust. So I don't think it's glamorous enough. It's not fast moving enough like craps. It's a game of chance. It's a pure game of chance. There's no betting involved, really. I mean, the payouts are basically bet on, they spin the birdcage, whatever happens, happens. So it's not like craps where you can choose to keep going and things like that. And it definitely isn't like blackjack or poker, where if you know something about the game, you can increase your odds of winning. Like when to stop playing, for example. So this just isn't quite as glamorous as those other kinds of games that are still in popularity. Are you watching the number of 5s on the current roll up there?
Yeah, there's.
What number are you not seeing all that much?
3.
Yeah, have we seen one yet? We must have seen one. I see a number registered over there. Looks like it's happened 9 times. Yeah? Looks like it. Oh crap, it just happened twice. Does again! Again! 13. Let's let it go for a little bit longer. This is kind of watch. We're actually within a 0.5% of what the true values are right now. We're within a 0.5% of what the true values are right now. And the true values, I keep saying these true values can actually be gotten by looking at the distribution called the binomial distribution. And we'll get back to that next week, like I said, towards the end of next week. No, towards the one class I see you in next week.
Is there a motorcycle thing today or what?
Well, I don't know. Lots of mufflers have fallen off in the.
Sometimes they're going to get a last Friday.
I think we're getting pretty close. Have they moved much recently? I think they're pretty much stable now. They pretty much stabilized what they're going to do. I'm going to grab the stapler. We'll use these numbers. Right there. All right. So we've rolled 3,297 times. Of that 3,297 times, just over half, or 57.58% of the time, you did not get what you bet on. So more than half the time, you didn't get what you bet on. But here's how they really get you. Roughly 1/3 of the time, you do get what you bet on one of those, which means you won your money back. So that means roughly 92% of the time,
You're making nothing.
well, you break even right there-ish, if you will. You lose $1 in one and you gain $1 in the other, so that's almost how they keep you going. But the trick is, this is still happening more than that's happening. So, what I want to do, I'm going to leave this up. Head on 4 again. Let's fill the distribution in, and let's analyze. Let's use these values. The chance of losing $1 is 57.58%. The chance of breaking even, 3,415. The chance of gaining an extra $1 over and above what you lost, about 7.6%. And last but not least, under 1%, 0.0067. That, if I remember correctly, and this is always cause for concern because I usually can't, I think that's a little high. I think it should be 0.005 for that last one. I think we saw that little spike of 3 5s there in a row, from 9 to 10 to 11 to 12 to 13 really quickly. That should only happen 1 in 216 times. What? What the hell is he talking about? 1 in 216 times? Where are you going to get 1 in 216 times from? Why is it 1 in 216? Where does 216 come from?
From all the possible rolls.
Heidi, we're rolling 3 dice. Remember how we said there were 36 possibilities for 2 dice? 6 times 6. 6 times 6 times 6 is 216, and only one of those 216 is 555. Just one. It's a triple. It's like Snake Eyes, but with 3 dice, if you will. So it's 1 in 216. So every 216, so roughly every 200, you should see your 3 5s come up. That does not mean that you have to go 200, then 3 5s, 200, then 3 5s, as you just saw. You just saw a cluster of them happen right at once. Why did we see that? Because randomness does that, right? That's the whole point. Randomness does that. I love the way it happens. And that's the best part about probability. It happens no matter how we define things. Actually, that's capturing it pretty well. All right, I'm going to shut this down, turn this up, and you guys are going to tell me, on average, how much do we make in this game? On average, how much do we make in this game? Do we have all the information we need now? Do we? Yes! This is all you need, friends. This is all you need. L1, L2, baby. All you need. All you need. All you need. I just said that like 12 times. I apologize. All you need are the random variable values, which are the winnings, and the likelihood of those values, which are the frequencies, or in this case, relative frequencies. Yeah. I'm going to put this...
So,
Please go, Madeline.
if you have a 1 in 216 chance of
Yes.
all 3 dice,
Yes.
what is it for 2? I'm trying to...
This is a fantastic question, which I'm going to delay the answer to, but I want to rephrase it. What Madeline just said is, I'm not following. You figured out the 1 in 216 for the 3 5s.
See, that's easy.
The
Yeah.
kicker with the 2 is you have to account for all the possibilities. Now you have to think about it. If you're rolling 2 5s with 2 of the 3 dice, you have to roll a non-5 with the other one.
Right.
But then you have to decide which die has the non-5. Is it the red one, or the blue one, or the yellow one? I'm going to delay the question
Okay, because
until we talk about chickens. It's more complex than, remember how I told you beginning of class? On the project, we focused on the at least one, at least one, at least one, and it was all about nones or at least ones. This, you're asking me to get into the middle of the distribution. These 2 are very easy to figure out. The all or nones. The chance of getting no 5s at all is 125 out of 216. Now see if you can buy that. There are 5 non-5s on the dice, 1, 2, 3, 4, and 6. In order to not get any 5s, it's 5 times 5 times 5, or 125 possible ways out of the 216. And that, 125 out of 216, is roughly equal to this guy right here. And the 1 in 216 is roughly equal to this guy right here. The other, whatever's left, splits here, but your question is great. So I don't want to delay it because I'm a bastard. I want to delay it because I want to focus on this distribution idea and then get into the guts of it, if that's fair.
Yeah, that's...
It's a fantastic question, and it's one that needs to be answered, of course. But I also don't want to get bogged down in it right now because I want to focus on one. I've learned to focus just on averaging the distributions first and then getting into the nuts and bolts of it. And the chicken, my chicken flock is a perfect way of doing it, so we'll come back to that. All right, let me get caught up with you guys. You got me an average? Hell yeah, you do. 1, 0, 1, 9. And there's actually an equation for it too, Matt, to answer your question. There's an equation that generates those numbers, much like the one we just looked at for the rolling 2 dice. But we'll come back to that as well. 0.5758, 0.3415, 0.0758, and 0.0067. I'm going to check something real quick. I'm going to sum those up.
That's going to be hard to see on the video.
Oh, it is, isn't it? Sorry, don't go to sleep on me. You know it's hot in here. I'm gonna sum those up real quick just to see if they sum to 1. Oh, look at that! Rounding error. That's a rounding error. I just added up the probabilities in list 2. Not quite 1 due to the rounding error in Excel's calculations. On average, it'll round to 1. Sometimes you'll get 1.001s and things like that. But we're a little bit under. That's okay. I can live with that if you guys can. Okay, totally fine, rounding error. Okay. If I want to figure out what I'm averaging on this game, what does it mean? What are we going to do? What are we going to do? Same thing we've been doing this week too, huh? Yeah? Stat, count, 1 bar. Make sure though, because watch what happens if you don't. If you just go 1 bar stats, the average comes back at 2.25. Just like we said it would, right? But this makes the assumption that you're just as likely to roll 3 5s as you are to roll none. We can't do that. We've got to tell it L1, L2. How we doing on average, friends? We are losing about 44 cents every time we play this game.
No, I can't wait for different numbers.
So in other words, here's a better idea. Walk up to the game, hand the casino dealer $1 and say, just give me 56 cents back and we'll call it good. Honestly, that's what that says. This says you lose on average 44 cents every time you play the game. So why bother playing? Walk up, hand the $1, ask for 56 cents back, and walk away. Then you go back up and play again. Hand 56 cents, ask for whatever's left, 22 cents back, 12 cents back, walk away again. Then you're bankrupt and you can go home. But this is a guarantee, friends. This is a guarantee. This is if you play the game long enough, on average, you will lose. Now, how does Vegas rope people in?
The once in a while that you get the 10.
And did you see what happened when we were playing? Boom, 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 boom. A whole bunch of 3 5s happened at once. What does Vegas do when that happens?
Ding.
Oh, the lights go off and the bells ring, and oh, we just had a winner at seat 18A, and everybody runs 18A and tries to knock the old lady off. Or they walk around waiting for the machine that's hot and that's due. Absolute crap. Absolute crap. Could you have predicted when that cluster was going to come up there watching Excel? Of course you couldn't have. You could watch it on average and you could say, okay, it's been a while, maybe we're going to get one. No. Crap, there they were, 3 in a row. You can't. You can't. You can count cards, but you can't count independent events. That's the problem. Counting cards, fantastic hobby. Fantastic hobby. I wish I could do it better. But that's actually doable because you can keep track of what's left in the deck. These are independent dice rolling every time. You have no idea what's going to come up because it's not conditional upon what's already happened. Make sense? It's called the gambler's ruin. There's an old strategy for a guaranteed way to make $1. Here's a guaranteed way to make $1 in Vegas. I'm gonna turn this off, talk through it. Forget Chuckle Up for a moment. Katie, go ahead.
This might be kind of off topic, but how can people get, like, 'cause I know it's illegal in casinos to count cards. How do they?
It's not illegal.
It's not illegal.
It's not illegal at
Frowned
all.
upon.
They just don't like it
Oh.
because you win their money more than you should.
Okay.
They ask you to leave. There's a great book, Bringing Down the House. If you get a chance to read one book in the next 3 months that will help you with this class. Bringing Down the House. The movie 21 was based on it. So if you see the movie 21, first of all, nobody ever got beat up. That was crap. That was Hollywood. But the book is fantastic because it explains the math behind what was actually going on in that movie. It's not illegal, but they'll ask you to leave because they don't want you doing that. Guaranteed way to make $1 in the casino. You ready? Find a game of chance. Find a game of chance that has a 1-to-1 payoff and 50-50 chance of winning. Go up, bet $1. Okay? If you win, you get your $1 back. You go home. If you lose, bet 2. Now you're down $3. With me so far? Play again. If you win, you get $4 back, which cancels out the $3 that you lost, leaving you with 1. If you win. If you lose, bet 4. Now you're down $7. But if you win, you'll get $8 back, which cancels your 7 and leaves you with 1. If you win. If you lose, see what's going on out here? Bet 8. So every time you lose, just double the bet that you bet before. And eventually you'll win $1. The problem is, on average, it will take you an infinite amount of money to actually win the $1 back. That's the beauty of Vegas. People don't go into there with an infinite amount of money in their pockets. They go in with, say, and one of the things that pisses me off the most about Vegas, the ATMs in the lobbies, that pisses me off so freaking bad. And then outside Vegas, the billboards. Gambling problem? I wonder. Anyway, soapbox off. What does this have to do with your life outside of gambling? What does this have to do with your life outside of gambling? Can you see how this would apply to anything that you guys deal with on a daily basis? How'd you guys get here today? Did you drive? What do you have to have when you have a car? Well, gas, good. I was thinking more Uber. Yes, gas, a key. Oh, seatbelt.
Still sad.
Thank you, guys. That's awesome. It's totally awesome. Yes, gas in the tank. Yes. Sydney. Oh, you're just stretching. Good. So we have to have gas. We have the keys, which is sometimes very challenging early in the morning trying to find your keys. Where did my kid put the keys in the toilet? Flush down the toilet. What else? Legally, you're supposed to carry insurance, right? Legally, you're supposed to carry insurance on your car, right? How much do you pay for insurance? Don't tell me this because it's none of my business. But I guarantee too much. But I guarantee it varies from person to person based on what factors?
Driving record.
Driving record,
Age.
gender, age.
Mother car,
Marital
your mommy
status.
discount.
Oh, discounts. Discounts are a different animal because they're not so much statistical, although actuaries do use them statistically because they realize that they give too many discounts or lose too much money. Good. All that's very good.
How many people are on your?
Absolutely, because there's a statistical tie between that and discounts and also likelihood of incidents. Good. Lots of things.
How much you drive?
Mileage driven, yes. Mileage driven, absolutely. All of those things are fed into actuarial computers and payments are kicked out. In much the same way, these payoffs right here are generated because they know what they want this to be. They want that to be what? What kind? Well, they keep, Stacy, thank you.
Negative.
They keep an eye on what makes that 0. When that 0 is out, it's called a fair game. Fair because nobody makes money on average in the long run. Later on, I'll ask you to actually analyze what payoff here would make that 0. We'll come back to that. Once this kind of sits in a little bit. They keep an eye on what makes that 0, and they bring this in below it, which makes it negative. Now, what I'd like for you guys to do right now, and I've got a little in-class quiz prepared for us. We're going to close out the day with this. You can pair off with somebody else if you want to. I did a little bit of CDC, Googled it on myself, and I figured out the chance I die within a year, 0.269%. Based on my age, my gender, my location, where I had to use Portland because Ben wasn't in there. Portland,
Well,
Ben.
not so much higher chance.
Maybe. I don't know. I didn't get into their computer to see how they were calculating my odds. I'm guessing it was all guys my age, all guys in my location, 269 out of 10,000 died or out of 100,000 died in the past year, so therefore it became me. So, 0.269% chance of me dying in the next year, 12% chance of me being disabled and unable to work in the next year. which I thought was interesting. That's a 1 in 8. That blew my mind a little bit. So I also then looked up an insurance policy on me being either dying or becoming disabled. And I got, if I die, my heirs make 10 grand. If I die, my heirs make 10 grand. They'll pay me 2 grand if I become disabled but I don't die within the year. And this costs me $360 for the year. The policy would, if I chose to use this policy, be $360. What I want to know is, on average, what's the company making on me? Or losing on me? That's what I want you guys to play actuary, okay? I want you to play Vegas odds setters. Or better yet, you can't set the odds, you can set the antes, okay? So if you want to pair up with somebody, by all means do, otherwise you can work alone. I'll be wandering around to help you. But this is what gets interesting, and at the very end we tie into a gambling game that happened in New York that I couldn't help but